Hello. Today we're going to be solving systems of linear inequalities. So a system of inequalities is where you have more than one linear inequality put together. So you see kind of this bracket here grouping these together. So that is new to us. We don't know how to do this yet. But based off of what we did previously, we know how to graph this first one. So we're going to go ahead and do that. So our y-intercept is -2 and our slope is 1. And we're going to go ahead and graph a dashed line because this is not equal to. And then we're also going to be doing shading. So to do shading, we're going to go ahead and test 0, 0. We get 0 is greater than -2. This is true. So for this one, what we would do is we would normally shade above. Okay, so that's what we've done in the past. We also then can use that to do this bottom one. So we're going to go ahead and graph our y-intercept of +1 and our slope of -1. And so doing this, then we're going to go ahead and create our line. It is going to be a solid line because the or equal to part is there. So for this line, I'm going to pretend like the blue graph is not on there, and I'm going to go ahead and I'm going to just do this one by testing 0, 0. If I plug in 0 for y and 0 for x, I get 0 is less than or equal to 1. This is a true statement, which means that 0, 0 is going to work for this one. And so for this one, I'm going to end up shading the part with 0, 0. So for that line, I'm going to shade everything below it. So looking at this, we graphed one line, then we graphed the other, and we did all of our shading and everything with it. So we kind of know how to do it when we put them all together. It's just graphing each of them individually and then saying here, where are they intersecting? Where are they overlap? Okay, where's the overlap? Because we don't necessarily need only the blue points or only the yellow points. The solution to putting this together are the points that make both of them true, which is going to be where we made green here. So it's this part right here would end up being the solution. Okay? So looking at this, we want to circle the points that are the solutions to this system of inequalities. So 0, 5 is up here. It works in blue, but not in yellow. So 0, 5 does not work. -5, 0 is over here. It works in both blue and yellow. 5, 0 didn't work in either one. 0, -5 works in yellow, not blue. And -4, 5 right here is on the line. So the only reason if I know how to circle it or not is if it's a dashed line or solid line. Since it's on the solid line, it works. If it were on the dashed line, it would not. So therefore, in the system of linear inequalities, the solution is the overlap. So if you have different colors and you graph things with different colors, it makes things a little bit nicer to actually identify what that solution would be. Okay, so let's go ahead and try another one. So we want to graph this first one. I'm going to graph it in blue. Y is less than 2x. So I start at 0, 0, and I go up to over 1 for my slope. This would be a dotted line because it is not or equal to. To figure out the shading, I'm going to test a point, but here we go. We can't test 0, 0 because that was one of the points on the line. So I have to test something else. So honestly, I'm just going to test 1, 0. So I'm going to plug in 1 for x and 0 for y, and I get 0 is less than 2. This is true, which means for blue, I'm going to end up shading this side over here because my test point gave me something that actually works. Now I'm going to go ahead and graph this next one. Y is greater than -3. This is a horizontal line. So I'm going to go to my y-axis and I'm going to go down to -3. I'm going to put a dashed line here because it's not equal to. And I want everything greater than. So what I'm going to do is I'm going to go ahead and take and I'm going to shade everything above, or again, we can test a point if we want to test 0, 0. We get 0 is greater than -3, which is true, which means we want to shade the part with 0, 0. We shade everything up here. So before we finish up, we have to look for where we are overlapping. So we want wherever blue and green were shaded together. So that is going to be this section here. So I do want you to take and darken that in more so that we know that this part right here is your solution. Okay, so you need to identify that overlap is actually there. So let's go ahead and try this next one then. We're going to graph this top equation. It's in slope-intercept form. So I graph 1 as my y-intercept and -2 as my slope. For this line, it is a solid line because it says or equal to. I'm going to test 0, 0. It's right here. So 0 is greater than or equal to 1. This is not true. So I can't shade the part with 0, 0, so I would shade up here. Now I'm going to graph this next one, but I have to put it in slope-intercept form first. So I add x to the other side. And my y-intercept is 2, and my slope is +1. So I start up at 2, and I go up 1, right 1, or down 1, left 1. And then my line here should be a dashed line. So for my red line here, I'm going to go ahead and test 0, 0. But I am going to test it in my original equation, and I get 0 plus 0 is greater than 2. So 0 is greater than 2 is false, which means for my red line, 0, 0 can't be in the shaded region because it did not work. So I'm going to shade the opposite side. So I am now looking for where red and black are both shaded together, and that would give me my solution. So it is this part up here. You do want to shade it kind of differently. Sometimes there's a lot of like colors there. So just somehow make it known that this part right here is my solution. Okay, let's go ahead and have you try this one. So pause the video and try number 4 and then unpause it to see if you got the correct answer. Okay, so far you can see that the red line there is a dashed line and it's shaded below. The blue line is a solid line and it's shaded above. And so looking at this, we are looking for where both red and blue are shaded, which is this region right here. This would be my solution set. So now what we're going to do is we're going to go ahead and look at the system of inequalities, and we're going to write a system of inequalities shown by the graph. So we're going to go ahead and look at two different equations, the blue one and the red one, and then we have to use where our solution is to identify greater than or less. So let's start with the blue inequality. We're going to compare y, and my slope right here is down 1, right 1, so my slope is -1. And my y-intercept is 4. And looking at my solution set, blue got shaded above, which means it's going to be greater than, and it's a solid line, so it's or equal to. For my red one, my y-intercept is 3, and my slope here, I go up 2 over 1, and it's not equal to because it's a dashed line, and I shaded everything below, which means it's less than. So let's go ahead and try one more problem here. We have this blue line and we have this red line. So for the blue line here, I'm going to put it in slope-intercept form. So y equals something x plus something or minus something. My y-intercept is down here, but notice my scale is not by ones. So this is actually -4 for my y-intercept. For my slope here, I'm actually going up 2 and right 4. So if I take up 2 and right 4 and reduce it, my slope here would be 1/2. I notice it's a solid line, so it's going to have the or equal to. And for the blue, here's our solution set overall, but the blue is shaded everything below the line, which means it's going to be y is less than. For the red, my y-intercept here is 0. So my y-intercept over here, I'm going to have a 0 there. And my slope, I'm going to identify the next nice point. So my slope here is down 4 because, again, the scale is different, and then right 2. So if it's down 4 over 2, my slope here would be -2. And for my red line, it's everything above that is shaded. So that's going to be y is greater than that -2x. And those two together represent my solution, or this system of inequalities that give us that solution there. So thank you very much for listening. Let me know if you have any questions. Thanks.